All right, pre-calc 11. We're doing trigonometry right now. We're jumping into new trig without 90 degrees. So we're going to look at, in the textbook, I'll actually do the chapter actually completely backwards to the way it's in the textbook. So we'll actually be doing the last section of the trigonometry in the textbook. So we're going to do what's called the cosine law. Looks overwhelming at first, like anything in math, but take a gander at what we have here. Okay, so first of all, if you're dealing with a triangle that is not right-angled, what would happen in grade 10, if you had a non-right-angled triangle, you would actually split this triangle up into two right triangles and then perform Pythagoras and SOHCAHTOA and mix the two triangles together and do a lot of multi-triangle question work to get to the answer. But someone figured out that if you mixed those together, you can actually come up with what's called the cosine law. If this interests you, the actual proof for it is right here, which I'll hold up. It's in your textbook as well, but I'll hold that up there. You could read through that proof of where the actual cosine law comes from if it interests you. I'm not going to go through it. It is detailed but fun. That's my Friday night math party right there. So here is the cosine law formula. It basically is three forms. I just use one form, as you'll see in a minute. If you have a triangle with sides and angles ABC, as we talked about earlier, you can use either one of these forms. And notice it looks like Pythagoras on steroids, really. So there's kind of Pythagoras, c squared equals a squared plus b squared, but then there's this weird minus 2 times a times b times cos of angle c, or you could write it in this form. Because this is not a right angle triangle, a, b, and c, nothing to do with hypotenuse or adjacent opposite at all. It's just a declaration of the letters. I use this form. I use where the a squared equals b squared plus c squared minus 2 times b times c times angle times cos of angle a. And we'll show you how to use that. So that'll be the formula you will use. And when you use the cosine law, you're going to use it for two situations. You're going to use it for a situation like this, where you have a non-right angle triangle. You have two sides that are given, and you have the angle in between, and that's called a contained angle. I call it SAS, S-A-S, meaning side, angle, side. The angle that you have is contained between. And you're going to be finding then the opposite side, or the side that you're missing. The reason, again, you can't use Pythagoras here is because it's not a right angle. As soon as it's not a right angle, SOHCAHTOA and Pythagoras are useless. The other case would be if you have three sides given, and you want to find any angle. I just happen to put that angle there. I call this SSS, side, 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 and you're finding any angle of choice, and we'll go through that an example of that as well. And I just remember this, it's corny. Cosine law, I just remember like this is just the snake makes a s sound, and sass, and so it's just a little sassy snake. My snake is called Sassy. It's corny, works for me. Here's the first example, or first two. Let's look at this first one together. So here we have a triangle, no right angle triangle. So right now, grade 10 is out the window, unless I want to create right angles, but I don't feel like it. We're going to learn the new stuff. So the triangle happens to be labeled TVM, and this side here is 17 centimeters, this side here is 15 centimeters, and the angle between them is 21. Now in the old days, before trigonometry was invented, they would just draw this with a ruler and a protractor and then measure that. And there's nothing wrong with that. That's just not trigonometry. That's geometry if you want, or just architecture. That's just drawing it out. The beauty of trig is we can find out the side TM. We can figure out this length right here without grabbing a ruler and a protractor using the mathematics. So first thing that you will do is you will look at this and say, what do I have? Well, today's lesson is on cosine law, so obviously it's cosine. But if it wasn't, you would look at it and go, non-right angle triangle, side, angle, side. So I have the SAS. I know this is cosine law. And right away, once I know it's cosine law, then I would write out the formula that we talked about earlier. And you'd be given that formula. I mean, if you use it enough, you'll memorize it or you'll tattoo it to your heart. I'm just going to write it out here. be diligent with it. When you're doing your homework, you just have it at the top of your page. You wouldn't rewrite it every time unless you like writing. The main thing for using this though, and this is the key, once you get it set up properly, it's a piece of cake. You just have to notice that in the formula, this little a and this big A, those are always angle side opposites. So you have to make sure whatever side goes into little a, this has to be the big side, the little angle, or the big angle across from it. So the only choice here is, in this case, if you look here, the only angle side pairing that even exists is the side that we want and that angle. Because this angle here, I don't care about it. So this has to be my A. So the side we're finding here, even though it's called TM in the picture, from the formula, this is going to be A. I'm going to write it out in pink. So that's little a. Hence, if that's little a, V is my big, there's my quotes, big A. All right? Once you get that nailed down, then your B and C are your other two sides. You can label them however you want. Now, even though I know this is little m, I'm going to call that little b. And then I'll make this side little c. So if you want, I've totally renamed the triangle. The triangle is no longer TVM to me. It's triangle, this is big B, this is big C. I've only done that because that's the way the formula comes in, but really it's TVM. I'm just using A, B, and C as the pseudo names. So now once I've got that labeled, I just go in here, okay, little a, don't know it. So I'm going to call it little a still, or X. Some people do that. They would just call this X and put X there. It's a great way to do it. Little b, according to my labeling, 17, so 17 squared. Little c, 15 squared. And then in here, I'm multiplying, so put in brackets, little b is 17 again, little c is 15, big A is 21. And then you end up with this big mess. There's two ways you can do it. I'll show you. You could do it step by step. You could do 17 squared, 289, 15 squared, 225, 2 times 17 times 15 times cos of 21. Get this ugly answer. And then add and subtract all those together. I personally prefer just to type this whole string into the calculator. The calculator was invented to do the work for you, so let it do the work. So 17 squared plus 15 squared minus 2 times 17 times 15 times cos of 21, making sure I'm in degree mode, which I am, and press enter, and you end up with 37.873 blah 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 blah. But be careful, this is a squared, just like Pythagoras. So to get a, you need to square root that final answer. So the square root of that answer is 6.1454. And if I look at the rounding, didn't say what to round to, so you know what, I'll give them 2 decimal places, 6.15, and the units for a length would end up being centimeters. All right, another quick example here. So I look at this one here and it's like, okay, it's SAS again. Side, angle, side. There's my angle. I know that has to then be my big A, hence this is little a. And then my other two sides, B and C. Doesn't matter which one's B, doesn't matter which one's C. There's no hypotenuse here whatsoever. Write out the formula. So over here's my good old, I know it's cosine law because it's today's lesson, but also more importantly, all right, so in for A goes X, in for B goes 20, in for C goes 11, and I'm just using brackets for all this here so it doesn't look like, looks like timesing, and then cos of 125. Now this is the first time without, this is not a right angle triangle and that angle is bigger than 90. You can actually do angles bigger than 90. So you go to your calculator, 20 squared plus 11 squared minus 2 times 20 times 11 times cos of 125, enter. I even take it one step further. I just write this out and give the person just one step of work, and the rest goes to my calculator. So I should do that again. I would just go square root of 20, all in brackets, 20 squared plus 11 squared minus 2 times 20 times 11 times cos of 125. And then I've done the answer. I've already square rooted it to boot. So it's done. I'll give them 2 decimal places again. I'll look at my answer and ask myself, does that even make sense? Does that look like, I've drawn it not to scale, but I've drawn it relatively okay. Does that look like it should be around 27.8? Does it make sense? Yeah, it does. And the units would be, in this case, length, meters. Okay, so that's the SAS. Let's look at a SSS, and then we're done. So consider this triangle. We're given 3 sides, not right angled. Even though it looks right angled, I cannot assume that's right angled. Now, I could prove if this was right angled by just checking Pythagoras. Is this squared plus this squared equal to that squared? And you can try it, it's not. So never look at your picture and say, oh, it looks 90. That's not, you never ever do that. You have to always err on the side of caution and say, nope, okay. Can't use Pythagoras or SOHCAHTOA. It is SSS, so it is cosine. So I go to the formula, write it out properly. Once I write it out properly, now comes the labeling. Now what do I want? It wants me to find angle QRP. Where's QRP? QRP. It's right here. They want that. Okay, so that's, I'll even call it, I can call that theta. Let's call it theta. Why not? Or X, or whatever angle you want. It's angle R, actually. So I look at that and go, okay, I need to use this formula. I know there's only one spot for an angle, and I am finding an angle. That must be, this has to be my big A. There's no other place for it. So if that's big A, that makes this side have to be little a. Has to be. And that's really important, because if I had made this side little a, I would have been finding this angle across from it. So once I've labeled my big A and little a, the other side's just simple, B and C. Alright, go to my formula and go, okay, I know little a, it's 14. I know little b, 19. I know little c. Write all the rest in as I'm going through, and the only part I don't know is angle A, which I could keep that big A, or I could call it theta, doesn't matter. And now the trouble is, I'm trying to solve for this, which is a little bit more work than the last example. So we're going to have to do some algebra to get to isolating that. So you have to do this, there's no quick way like the last example. So you have to square these. So 14 squared, 196, 19 squared, 361, 12.2 squared, 148.84. I can multiply those three together, but I do not know what that is, so I can have to leave that as a coefficient. So 2 times 19 times 12.2. 463.6 times cosine unknown. Now be very careful here. On this side, the only thing I can do mathematically, I can add these two together because they're numbers, but I cannot subtract this because it's multiplied by this part. So never be tempted to go this plus this minus that. You can't do that. All you can do is add those two together. So 361 plus 148.84, 509.84, still subtracting this. And that's so tempting to the mind, but you can't touch that yet with a 10-foot pole. The only way to get out of this, to get this by itself, because right now we're trying to get this we're trying to get cos theta by itself to lead to theta. I'm going to then move this, the 509.84, over to the other side by subtracting it. So it's a little bit of grunt work. 196 minus 509.84, I get negative 313.84, and it leaves me with my negative 463.6 cos theta. Now the only way I can rip this away from that cosine is by dividing. So I divide both sides by 463.6. And it looks messy. You'll always get these weird, ugly fractions. But finally I've got cos theta by itself. I'll go this divided by my negative 463.6. You get 0.6769 da 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 da. And remember that's haven't got my angle yet, but I'm one little baby SOHCAHTOA step away. How do I find an angle when it kind of looks SOHCAHTOA-ish at that point? You find the angle by doing the second cos button. So I would recommend keep all the decimal places in there and go second cos of all those 0.67 blah, blah. I'm just going to cheat and put the answer in there. And I get 47.39 blah 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 blah. And the units on an angle, degrees. Now that makes my little math heart go pitter patter because we've found that exact angle without picking up a protractor and a ruler. We know exactly what the size of that angle is based upon the size of those 3 triangle sides. So there's our answer. If it interests you, and we'll end there, in the textbook again, which it's just a matter of what you might want to take a look at. And you can pause it here once I open it up to it because I'm not going to go through it in detail. But for those that like kind of neat little tricks or little different formulas for it, there is a way of doing all of this with a formula. I kind of like it, but I kind of don't because it makes me not know what I'm doing. If you take a look at that example there, they've manipulated the formula first by solving it for, in this case, big C. Then they've plugged in the numbers at that point and got the answer directly. It's a matter of your preference. Take a look at that if you like algebra. Okay, so we'll end there. As far as the homework goes, the practice, which I'll put in the assignment, is page 119, 1 to 4, 7, 9 to 10. Have fun getting triggy with it, and we'll talk to you later.